This Week in Radio Tech, episode 169, is brought to you by the Omnia 11 Game Changer, the Omnia 11 FM audio processor, available with HD processing or FM only on the web at omniaaudio.com/11.
And now, our feature presentation.
Twert.
Many, if not most, AM stations are dying. Some owners have turned in their licenses and walked away. Would digital tech save the AM band?
All right, calm down. He says that to everyone.
This calls for immediate discussion.
What's up, Dad?
All your days are belong to us.
From his palatial office of important business.
Or in a choice hotel in a distant land.
This is Kirk Harnack.
Tom Ray and Chris Tobin join me along with our guest, Glynn Walden with CBS Radio Engineering. Let's roll.
You're dialed in to This Week in Radio Tech.
Hey, welcome in. It's time for This Week in Radio Tech. I'm Kirk Harnack, your host, and so glad to be with you. This is the show where we talk about radio technology. We talk about the stuff that broadcast engineers, well, especially radio engineers, care about. I've been doing this a long time. I got into radio because I stuttered too bad to be a disc jockey, and I couldn't make any money at it. So I've had a career of being a contract engineer and a station engineer and a station owner. So if you're watching our show for the first time, welcome in. And if you're an old hand at watching the show, man, have we got a doozy of a show for you. I'm sorry, I didn't mean to point, but this is going to be a good show, unlike some of our other shows. First of all, let's real quickly get to our co-hosts on the show, a couple of experts in what we're going to be talking about. First of all, from the Hudson Valley in New York, it is Tom Ray. Hello, Tom.
A guy who's a legend in his own mind. Hello, Kirk. Hello, Glenn. Hello, Chris. And hello, everyone. Good evening. And I'm, just so you know who I am, I'm president of my own company, Tom Ray Broadcast Consulting, and something we'll actually be mentioning tonight. I'm also the EAS coordinator for the New York State Broadcasters Association. So,
that's right. We have a tiny bit of topical news to open the show with. And also our other co-host, the best-dressed engineer in radio is what I love to refer to this man as. It's Chris Tobin from Manhattan, New York, except he's in an undisclosed bunker location right now. Hey.
Hello, Kirk, Tom, and Glenn. Yes, I'm here at the GFQ studios. We're having a good time so that we have room for guests and do things like this. And I'm with the folks at CCS Music Cam, and we do IP audio and video and a few other things. So it's good stuff. But tonight's going to be about AM radio. You know, we'll do this again at the end of the show, but I so often forget this. Chris Tobin, if folks want to check out your company, and I realize that you're a competitor to my company in some regards, but you also do video stuff that we don't yet. Or did I say yet? What's a website where folks can check out your gear, Chris? Oh, please do. You can check it out at musiccamusa.com. Links to all the stuff we do. And Tom Ray, where can folks find you on the internet?
I can't mention those places on a public show. Oh, no. No, it's TomRayConsulting.com. TOMRAY Consulting.com. That's where you'll find me.
TomRayConsulting.com. All right. Now, hey, here's our guest. We've been tweeting about this guy, and I've been putting this on Facebook, and I'm so delighted to have on the show, to bring on the show, Glynn Walden. He's the Senior Vice President for Engineering of CBS Radio. Glynn, welcome in.
Good evening, Tom, and good evening, Kurt. Good evening, Chris. Nice to be here.
Glynn, we're going to get to some really cool topics. And you spoke at the NAB show on their panel about AM radio improvement. And I hope that you're going to I missed that panel. I didn't get to go to it. I just heard a bunch of clutter cackling afterwards about the different ideas that were brought up and about this crazy Glynn Walden and his nutty ideas. And so I was immediately attracted. I said, I got to find out what Glenn's talking about. So we're going to get to that. And Glynn, I hope you'll give us lots of disclosure of your ideas for the AM band.
You know what? I wish I'd opened up my laptop before I started because I have some information in front of me. But, basically I started off with saying that there are a lot of proposals on the table to improve AM radio. And I think everybody knows that something has to be done in order to improve radio because we can't continue going on like this. I just yesterday I dealt with a lady who her radio is completely being noised out. She can't pick up her favorite radio station anymore, and the lady's not going to figure out the problem. It could be her cable modem box, which I find is a high source of noise. It could be CFL lights she put in her house, or whatever is completely noising up her radio. She lives in a strong signal area, so that's not the problem. And her car, turns out, is a 2003 Ford Explorer. And I can tell you exactly what happened to that car. The antenna has lost contact with the body, and the only way to tighten it is to remove the fender well, and Ford charges $80 to do that. Whereas 15 years ago, 20 years ago, any car mechanic would know you grab a pair of gas pliers and tighten the nut down on the antenna. On this particular antenna, it's underneath the fender well. So you got to take the guard off and all that to get in there. And that's the kind of stuff we face. It's just a constant noise is encroaching on the reception of AM radio. One of the proposals is for all the radio stations to get a power increase. And you have to start thinking about, well, how much of a power increase do you need? What's doubling the power going to do? 3 dB?
3 dB, yeah.
Quadrupling the power? 6? Is that enough? Is that enough to bring AM radio to listenability? Probably not. Probably the first number you might come to mind that would make a big enough difference is 10 times. So you say, well, let's see. For most of the CBS stations, that'd be 500,000 watts. Now, when we were Westinghouse, we had the nuclear division, so we could have put little generators at each radio station. But start to think about it, guys. You got to replace the base insulator. You have to put in all these new coaxes. You have to have a big transmitter. And look what happens to your electric bill. It's not a practical solution. It's not like you can say, oh, these guys will get the 10 dB power increase, but these guys won't. Everybody has to get it, or else you have a net sum zero change in interference. Everything you're doing is you're covering up the noise from power lines and Blackberries and Comcast power supplies and stuff like that. So that doesn't seem like a practical solution. A lot of them are really nice ideas that we should adopt. Letting people use low-profile antennas. In the old days, I guess they were concerned about that you had to meet a certain number of millivolts per meter at a mile with the antenna, and if you didn't meet it, at a kilowatt, then you couldn't get a license. Well, if you can't meet that number, so what? It's just less. It's not more. And as long as that antenna doesn't interfere, why don't we change the rules to allow that to happen? There are other things like a proposal to give every AM station an FM translator. Well, that's a great idea if somebody can find the frequencies for them. And as I said to Commissioner Pyle, well, good luck on that one. And they know that can't happen. So,
Glenn, I'm sorry, I didn't mean to jump in. You did a great job of kind of setting up what the problem is, or what one of the problems is with the AM band, and that is man-made interference. If you roll the clock back 20 or maybe even better 30 years before we had 3 computers in every house. I've got 5 of them here, I think. Comcast cable modem, you just mentioned. I didn't think about that as a source of noise. All these wall wart chargers that are using switch mode power supplies.
It's the power supply in the Comcast system is what it is. It's not.
Yeah.
They had a bad load of them that came in. They didn't meet spec from China.
All these CFL lights, and hey, real quick, I'll turn my camera around, and here's what's in my studio. CFL lights. I got a couple of big honking ones here that are shining on me. Each one of them has 4 bulbs. I can just imagine. No wonder my ICOM 7000 doesn't pick up much. I need the antenna farther away. There's all these sources of noise.
Can you bring my briefcase over? I'm just trying to get my laptop. Okay.
Sure. Take your time. We'll go on. In fact, let's bring Tom and Chris into the conversation. Tom and Chris, besides all the extra man-made noise, which really is significant. In fact, I should bring up that our friend, I'm sorry, his name slipped my mind right now, from Nautel, sales manager at Nautel.
Manteuffel?
Not Jeff.
Manteuffel, Gary, yeah.
Jeff's boss.
Oh.
Can't believe I can't think of his name. I'm so embarrassed. He's married to Desi.
Oh, I know who you're talking about. I can't think of it.
Oh, come on. I can't believe it. He's the guy that introduced me to the before the internet. Oh gosh, what's wrong with my brain? Anyway, he did a great presentation in India on the growing noise floor. What's that?
Oh, yeah, I'll remember his name in a minute.
So that's one thing. But there are other factors too. The noise is not just from all the man-made modern appliances that we have nowadays. There's also just as the rules of the FCC rules have been modified over time, and more people, especially throughout the 70s and 80s and 90s, tried to squeeze in more and more radio transmitters. We have so many daytimers across this country, so many places where radio stations are squeezed in, that what we end up having here is a situation that there's just if you're a class, what used to be called a class 4, maybe it still is, the stations that are on 1340 and was it 1230, 1270, all these stations that are kilowatt stations now, kilowatt day and night, man, it's like CB channel 19. If you scan the AM dial, and it stops at all these frequencies where there's all these kilowatt stations just day and night with Omni antennas. My goodness, there's so much noise there. How and AM is amplitude modulation. Well, you don't have a good capture ratio in receivers with this, so you're not going to hear one station or another on the same channel, the co-channel. You're going to hear a mix of stations going on. And by the way, for those of you listeners and viewers who may be airplane pilots, well, you know what I'm talking about. You know how absolutely rotten an aviation communication channel can get when there's a big pileup of planes coming in trying to talk to the same controller. That's AM as well. And so you understand the problem that AM brings about in terms of reception. So to me, these two things together, and maybe there's more things, receivers getting worse and worse. In fact, Tom, you've got some experience in this since you worked at WOR for so long. Talk to me for just a minute about AM receivers getting worse, less sensitive, more deaf, and more narrow-banded.
Oh, that happened. Started a number of years ago, Kirk. With as you know, if you widen out the bandwidth of an AM radio, that you start picking up noise from either side. Forget about the adjacent stations that you'll start hearing. You start hearing a lot more noise. You start hearing a lot of atmospheric stuff. You start hearing the sodium vapor light outside. You start hearing the LED traffic light that's up the street. You start hearing this computer monitor here. So the answer to that many moons ago was the receiver manufacturers took the bandwidth and started narrowing it and narrowing it and narrowing it. And well, now that's okay. You don't hear the adjacent stations, and now you narrow it and you narrow it. And next thing you know, it's worse than a telephone. And it's just horrendous. And but you don't hear the adjacent channel stuff.
You don't hear the adjacent channels. And let me bring Chris Tobin in. What did we do about this? Seems like in the 1990s with something called, at first it was NRSC2, with the receivers getting narrower. What did we do to what the audio we were transmitting on AM?
We generated more noise. Oh, I'm sorry, no, NRSC. Yeah, preemphasis. We applied preemphasis to the AM signal.
Well, we cut off the mask at 10. We limited stations to 10 kilohertz. But between 1 and 10 kilohertz, we just boosted the wee out of the high frequencies. And oh my gosh,
there was a competition between the broadcasters and the receiver manufacturers.
Yeah, that was big time competition.
And as we continued to increase our high frequency preemphasis, and by the way, prior to NRSC, we were using double 50 microsecond preemphasis, which is more aggressive than what the NRSC curve is, all the way out to 15 kilohertz. And so what the receiver manufacturers responded with is by narrowing the bandwidth of the receivers. And when they did that, we cranked up the highs some more, and they cranked the bandwidth down, and we cranked it up. And NRSC was an attempt to try to get the broadcasters and the receiver manufacturers on the same page. And it didn't work. Very simple. They didn't build receivers to meet the standard, and we all implied a tough standard on us to meet, and everybody pretty much complied with it.
Weren't there one or two or some receivers that actually were compliant, and then they have a logo on them of some kind?
I don't know if there was ever a logo, but there sure were a few compliant receivers.
Mm-hmm.
Yeah, Denon. I think
Denon
had a logo.
The AMAX?
AMAX.
Yeah, that was called the AMAX. That's exactly right.
AMAX.
Forgot that.
Yeah. Wow. So, there's some history. So we're stuck with this problem with AM, and I must admit, as much as I listened to AM so much in the 80s, 90s, early 2000s, here in Nashville, I used to listen a lot to WLAC, 50,000 watt station here in Nashville. But I don't know. I don't know if something changed in my car receiver or if I just got less enamored with the programming, but I can tell you here in Nashville, I don't listen to AM anymore. I know there are plenty of cities where AMs are still top dog or close to the top of the ratings. What's it like in New York City? You guys are all up in that area.
Well,
for AM.
The biggest dogs are the AMs there. Certainly for us, WINS, WCBS, WOR has been a continual performer. Hasn't been put out of business, so to say, by FM. WABC retained some numbers. So there are a number of successful stations there. For us, these are high billing radio stations that make a lot of money, including WFAN, which is now on FM. But I think we're still seeing the majority of listeners on AM, which doesn't totally make any sense.
Yeah. So what happens when you get out of the New York market, which has always been known for great AMs, and also maybe the San Francisco market, the Seattle market, where FMs are a bit hampered by a lot of multipath? What happens when you go to, say, Poughkeepsie, New York, or Knoxville, Tennessee, or Indianapolis, Indiana? Do you have AMs at the top of the heap in those cities?
No, not anymore.
Mm-hmm.
And those markets never really had stations with strong signals to begin with. I think one of the markets that always fascinated Westinghouse was the Washington market. We always looked for an AM to buy there to put all news on because we didn't have an all news facility. And WTOP struggled for years with a crappy signal, and all the AMs there's no good strong signals that cover the market in Baltimore or Washington, unlike you would have in Chicago with our AM WBBM or WLS or one of the other stations that really have dynamite signals that really do cover the market. And WTOP struggled along with a 2.5, 3, 4 share in the ratings. And we figured that in any given market, a news station ought to generate, news stations or news station ought to generate in the order of a 6. You'd say, but in D.C., where you'd think there'd be a lot of news listeners, the number of people listened were 2, 3, 4% the most until they went on FM. And then, wow, then it hit a 10 share. They've kind of fallen back from that. I'm more in the 9 and 8s. But that was more typical what that market should be. That's a news-interested, news-hot market. And the stations, 15 being high on the dial, WTOP just didn't cover the market.
Mm-hmm. So whether, to summarize the problem, whether it's man-made noise, which we know is a huge amount of it, whether it's the inherent, I shouldn't say inherent because it doesn't have to inherently be lower quality, but whether it's the practicality or the reality of lower audio quality on AM, or whether it's just less emphasis on the programming that goes on AM stations, it's less interesting, there's less good content in many markets, maybe even most markets besides the big ones that we've been talking about. All these things lead to the demise of AM. I had a radio installed in my car, 12, 13 years ago in a small town when I lived in Cleveland, Mississippi. And I asked the guys who installed the new radio about how was the AM reception and did they tweak the little capacitor trimmer and then they said, this was 13 years ago. Oh, ain't nobody listen to AM anymore. It picks up FM real good, but it'll play your CDs. And that was their attitude. I have a daughter who I don't think has ever listened to AM radio in her life. So going forward, Glenn, this is actually mostly what we brought you on for is to, we've set up what's wrong, why it's hurting. At least this is the reasons why we as engineers think it's hurting. Where is it that we need to be going? Do you think what needs to happen soon and long term?
I want to do a little setup on this, okay?
Yeah.
That because I really thought the words out carefully here. That is, there are a lot of proposals to solve the problem. Move the stations to FMs on Channel 6 and TV. And like I said, a lot of these other small things like being able to put a different type of antenna in or to allow a station not to have to make coverage of city of license anymore. What does city of license mean anymore in the world we live in, where it's how many people does it reach is really all that matters. And my comments were the AM transmission system is difficult and expensive to implement. The AM band is a hostile environment for transmission and reception. Analog AM modulation system is inherently inefficient, and AM receivers are cheap and bad. I think that kind of just sums up the whole thing about AM right there. And most of these proposals that you heard other people on the panel that I was on with, I support all of them, but they just nibble around the edges. They don't solve the problem of how do you fix it. And there's only two ways to fix it. One is to take channels 5 and 6, make them, and they have to be all digital channels because there's not enough spectrum there to accommodate all the AMs in 12 megahertz. Mm-hmm. They'd all have to go all digital FM, and then they could fit enough channels in. And that's somebody else's study, not mine. I actually haven't checked that work to see if it's true, but it probably is. They wouldn't be. The NAB commissioned the study. The problem is the FCC's not giving up channels 5 and 6 because they're going through this auction, this auction, where they're going to auction off all the upper UHF TV channels, and they probably are going to need 5 and 6 to move some of the stations to, so that every TV station can get a new home in this compacted band. So the goal is sell off the upper channels for wireless services, who, by the way, are one of the contributors with all their noisy wall transformers and everything to the demise of AM. And the broadcasters are opposed to it because they don't know what happens as a result of repacking, so they're opposed to it. The FCC is opposed to it. And also, what AM station is going to be able to afford one of those frequencies? Do you think they're going to give them away? They don't give away spectrum. They auction it. Where are they going to get the money? They're not going to get one of those channels is what it boils down to. Because it's going to be, when it goes to auction, it's going to be expensive. So I would say that maybe there might be enough spectrum to do it in one if they have a number of people who might actually bid on these channels. But I don't really see that channels 5 and 6 are going to happen. It is a solution that would solve the problem for AM, though. That leaves us with I had a little thing here about the inefficiency of AM, and I just want to give you a little example of how inefficient analog modulation is.
Okay.
The 50 kilowatt carrier of an AM station delivers no information whatsoever. It's just 50. It's just 50 kilowatts of a pointer that is used to demodulate the signal in a very inexpensive receiver called a diode. The 50 kilowatt AM station, even with all of our aggressive Omnia processing or their competitor, ends up with about 4.2 kilowatts of audio. That's the message. That's the RMS power that we actually get out of a 50 kilowatt radio station.
Wow. I didn't realize the ratio was that bad.
It's about 12 dB below the peak power is the RMS power, even with all of our aggressive processing. And I've done a lot of work when I was working with Ubiquity where we actually quantified this stuff. And while it's not germane to this particular discussion, the AM HD radio system delivers about 1.5 kilowatts of power, 1.4 on a 50 kilowatt station. So it doesn't even deliver as much message power as the analog modulation does. A 50 kilowatt all digital station delivers 33.5 kilowatts of message. That's the advantage. 4,200 watts versus 33 kilowatts of message.
That's eight times better efficiency.
That's right. That's why it works. That's why it works better than analog. Also, it'll recover audio at about 16 dB signal-to-noise ratio, carrier-to-noise ratio. What do you think an AM radio station sounds like at 16 dB carrier-to-noise ratio?
Give me an idea.
It gives you the idea that it's hearable but not listenable, and I think that's the other thing that we have to face is you brought this up, Kurt, why don't you listen? Audience accept levels of acceptability have increased in the era of FM delivery, internet delivery. Sometimes internet delivery is not too good, and satellite. So people are accustomed to getting high quality audio without noise, and that just is not the normal mode for AM radio station operation. So those are the solutions that work, and they work well. And all these other things are nice. By the way, we should do all of them. We should change the city of license rules. No reason not to. We should allow lesser antennas. Every FM station, every AM station that can manage to find a translator should get one. Nobody in New York City is going to get one. No one in Philadelphia is going to get one. Probably no one in Nashville is going to get one. But in Poughkeepsie, they might find one.
Yeah.
And so I think that we should go through all these things. What?
Probably not with its proximity to New York.
Oh, really? So, okay. I don't know the map. I don't know where Poughkeepsie is that well, Tom. But that's all these are great ideas. We should allow them to happen. But we have to really look at where are we going. The truth of the matter is that anybody who wants to hang their hat on anything analog must be smoking something, because there is no future for analog.
So I guess people hang on to analog, and I get that. It's very romantic, and there's millions of receivers right now for it, and they're reasonably simple, or they can be. And I'm not going to argue with you about analog. I actually feel the same way, that you got to blow something up. You got to move forward. Are we really going to be planning on having AM radio in 50 more years from now? Is it really going to be anything that anybody wants to listen to? I can't imagine it getting better incrementally over the next 50 years, because it's gotten worse incrementally over the last 20, 30 years or so. So blowing it up and doing something different with it seems just logical to me.
The guys who build the HD radios, their analog radios are not just a diode detector. They have a real noise blanker in them. They do analog to digital conversion. All the processing is done in the digital. They control the bandwidth in the digital domain. They do a lot of things to make the radio work very well. But all those techniques, they're just, like I said about all the other, they're nibbling around the edges to what the real problem is. And the real problem is you have a very inefficient system, 50 kilowatts of power delivering 4.2 kilowatts of message. It doesn't work, and the noise is going to continue to increase. We're already seeing the noise levels. You can't hear it on FM, but it's happening on FM, that it's limiting the coverage of the radio, because it sounds like white noise up there.
Yeah.
No one realizes that as we see these devices creeping in, that they're slowly eating away at the coverage of an FM station. I go out running, and I like to go down the Jersey Shore when I'm down the Jersey Shore running, and I wear my little headphone radio. As I walk inside any store, gone. The noise level in the store totally wipes out the FM reception.
Oh, the FM?
I'm outside in the clear.
Wow.
I'm outside in the clear. It's fine. But as soon as I walk in, the cash register, the TV, the flat screen TV, or whatever, when I walk in the store, they're gone. And I'll admit the signals aren't that strong at the Jersey Shore, but there's a station not more than 10 miles from where I am, and it suffers the same fate. As soon as I go indoors, it's gone.
So now, the AM band, there's been people in various forums, someone had said, I just read today, the AM band was never designed for digital modulation. It needs to be analog. Well, I find myself disagreeing with that on its face, but how would you answer that?
Well, actually, if you look at the original digital mode, we started off with digital. It was called da-da-da-da-da-da-da. That was right.
Yep.
By the way, all the power of the carrier went into the message. It was 100% efficient.
Yes, it was. You're right.
So that was the original form of digital modulation. So no one told those guys it didn't do digital modulation. It's difficult to do. It's difficult to do digital modulation in the AM because of what we call grounded conductive structures. And that is, as you drive down the road or go into underpasses, the band is undergoing those very same sort of things that happen with multipath when you're driving down the road on FM. They don't sound like it, but it's the same sort of thing. And did a lot of studies when we were out driving. And one of the most difficult things for somebody who's designing a system is to actually compensate for these grounded conductor structures, so you maintain continuity of service as you drive down the road. And the other thing that's a problem, of course, is all this is being introduced into a band that has a lot of interference in it. Introducing a digital radio system into an existing analog service is pretty difficult to do because there's so much interference that exists because we don't even meet our own rules. We have rules on the FCC books. AM stations violate them, FM stations violate them. Now, a lot of the ones on FM, the rules came after the radio stations were on the air, so they're grandfathered in. But in AM, there was a theory that the FCC had is getting the maximum number of service to the maximum number of people. And so they would constantly compromise the rules in order to get a new radio station in Fairfax, Virginia, or someplace like that. Yeah. And today, the service areas of those radio stations are too small to be meaningful and competitive. If you go back and take a look at the AM radio stations that are successful in the air, what's the magic thing you're going to see about all of them? Come on, Chris, you know what the answer to this.
Oh, the content. I'm sorry, I didn't know you were looking for.
No, it's the power.
Oh, yes, power too. Yes.
If I take and if you put good content on WTOP AM, you're not going to really get the audience because they don't have the signal.
That's true. That's true.
Even though it's 50 kilowatts. So that's the hallmark of every successful AM radio station almost is 50 kilowatts.
Yeah. And some stations I've worked for over in my career, we were 10 and 25, but our market was small enough that we encompassed the listening audience with the signal. I'll call it a city grade signal, not a city license. So that would be the equivalent of the 50 kilowatt covering the footprint.
I worked for a successful 5 kilowatt radio station. We had very high ratings. But guess what? That station is not successful today, nor can it be. No matter, you can put the greatest programming on the world on that radio station, nobody's going to listen to it.
Yeah, if you don't have the coverage, I mean that's basically what it comes down to.
And you take a look at the stations. WINS is 200,000 watts of power over the city of New York because of the directional antenna system.
Yeah.
WOR is 50,000 watts on a great low frequency. WCBS is a 50,000 watts on a low frequency. WFAN is really low frequency with 50,000 watts. You look at the big stations in Chicago, they're low on the dial, 50,000 watts, very successful. In San Francisco, you have unbelievable ground conductivity, so 50,000 watts goes a long way.
Yeah.
You take a look at in Philadelphia at KYW, you got kind of a puny 50 kilowatt station. It's on 1060. Ground conductivity is not too bad. It struggles with good ratings, but it struggles, not as good as it could be, because it doesn't cover that far.
But then there's WFIL.
WFIL, which has no ratings left.
Yeah.
Back in the day, though, you remember.
Famous 56.
They were number one.
Yeah. Low on the dial. Low on the dial with the power.
That's right. We have, in Philadelphia, you have 610 WIP. And we have KYW on 1060. WIP signals much better than KYW's.
Yeah.
But it's 5 kilowatts.
I think the AM needs to look at other ways to deliver its content. And I agree with Glenn, the suggestions that are coming out to try and blow things up and make changes need to be addressed. But for the immediate future, AM needs to look at other ways to do it.
I would, what comes to mind immediately when you talk about blowing up the band or making a wholesale change is we imagine, and Glenn, maybe you can correct me, but we imagine that AM and full digital are not going to coexist very well very long. Who wants to spin their AM dial or punch around and hear a bunch of noise, their analog radio and hear a bunch of noise? How do you handle the transition such that AM stations don't lose all their audience overnight, what audience they may still have? And I realize in big cities with big signals, you've got plenty of audience. I own an AM station in Greenville, Mississippi, and sometimes I wonder if both listeners really care if we're off the air or not. I really think it's almost that bad. We do carry compelling programming, but I just can't imagine, don't know who's listening. Who knows? It might be 100 people, really. How do we handle a transition? How do we get the radios to pick this stuff up into the hands of Ma and Pa Kettle out on their farm in rural Mississippi?
Well, first of all, Ma and Pa Kettle probably aren't listening to AM radio anyway now, because they have the option of listening to FM, which delivers a more consistent and better listening experience. But you're going to have to set a date that says that on this date with outs. Outs are for the broadcasters, are the radios didn't happen quick enough or whatever.
Yeah.
That says that on this date, because there has to be a goal, just like they did in television. They said on this date we're going to turn it off, and lo and behold, 6 months later, I think they got one out.
Yeah, they got one.
They got one, and then 6 months later, I think it was supposed to go in January, went in June. It was done, over with. And you know what? Like I said, I go for a run. I saw a lot of TVs sitting out on the street afterwards with big tubes in them, and the flat screen revolution has taken over. It didn't take that long, and those analog TV sets, I'm sure there's a few people still using their analog to digital, their digital analog converter that they got nearly for free from the FCC. But most of those TV sets went away, and it happened overnight. And we might not have anything if we don't start thinking about a future. Then we have to assume there is no future. Bottom line.
Yeah. Okay. Well, Glenn, we're going to take a break for a commercial to hear from the folks at Omnia. And when we come back from that, I would like for you to help us imagine what a digital AM band would sound like and would behave like in actual practice. If I'm driving across Tennessee, listening to some big AM signal, and I guess I'm assuming that power levels would remain about the same, but the modulation would be digital. Maybe I'm totally wrong about that. So when we come back, let's talk about how it would work out from the consumer's point of view. You are listening or watching to This Week in Radio Tech. It's episode number 169. I'm Kirk Harnack, your host, and our show is brought to you by Omnia Audio and the Omnia 11 audio processor. The picture on the front here of the website says Game Changer. That is true. I have been to more stations that have Omnia 11 processors and heard even more of these stations. And I got to tell you, it's a game changer. The fatiguing processing that we got so accustomed to from the 80s and the 90s and multiband processing and even the early 2000s, so much of that fatigue is gone when you use the Omnia 11. The Omnia 11 actually analyzes the audio coming into it and decides, what am I going to do with this? If it's already dense enough, the Omnia 11 just backs way off. It says, I'm not going to touch this. I'm going to tweak it a bit here and there, but I'm not going to pound on this anymore. And that is totally unlike where processors have been for decades now. Processors for decades have been, you crank the audio in, you get it in the sweet spot, and it's just loudness controlled. A little bit of program, trying to, for example, affect the release time. But for the most part, processors have been really kind of dumb about the audio. Well, the Omnia 11 is really smart about the audio. We call it chameleon processing technology. There's also what we call an ultra multiband limiter system of incredible bass management. I mean, bass is so important to some formats, and I'm not just talking about something that hits you in the chest, but really nice, powerful, but smooth and controlled bass. Country radio stations, for example. Bass management plays so well on a country format when you've got a bass guitar just really setting the foundation for the music. Sounds so good. The Omnia 11 also has a feature. It's the ultra low IMD distortion control clipper system. This is something that Frank Foti and I think his cat Vito help him invent. The ultra low IMD clipper does an incredible job of doing clipping but not creating the intermod distortion products that any standard clipper will produce. So it really reduces the fatigue while giving you the same loudness as other clippers. There's something else that's pretty cool, and a number of engineers across the country have tried this. It's perfectly legal. It's called single sideband. Now, this is not like, well, it's a bit like amateur radio single sideband. In the FM spectrum, in the FM baseband, there's left plus right. There's the stereo pilot. And then there's this dual sideband suppressed carrier, left minus right information. Well, in the Omnia 11, you can turn off the upper sideband carrier. It's actually not needed by almost every receiver out there. There are some early receivers that were pre-PLL from 1973 and before that may get a little confused by this. But any other receiver is going to sound just fine with this, doesn't realize that this upper sideband is gone, and because multipath tends to make itself known when there's energy in the upper portions of the baseband signal, bottom line is it can reduce reduce multipath distortions. And we've had engineers tell us that they haven't heard a difference and that they have heard a difference. Depends on the terrain topology and where the signal's bouncing around. Bottom line is it's included. You don't have to pay extra for it. You can turn it on, try it out. You're not going to hurt any of your listeners with that. Huge touchscreen on the Omni 11. It's really cool to control. I've got one here in the office, but the timeout has occurred on it, so the screen is dark at the moment. It's got live wire in and out, so if you got a live wire facility, plug your live wire right in there and send your audio straight into it, out of it, whatever you want from that. Plus, it has several processors in it. It'll do HD radio processing for your HD1. It's a whole slew of features. It is gorgeous. It's fanless, no fans. It looks cool, and it stays cool in the rack. I want you to check it out. Go to the Omnia Audio website. It's Omnia Audio. That's OMNIA, omniaaudio.com/11, the number 11, and check it out. Thanks a lot to Omnia for sponsoring This Week in Radio Tech. I dearly appreciate Frank and his crew, Cornelius Gould, Rob Dye, Mark Manolio, and the guys who are behind this incredible processing technology. Low fatigue, lots of volume, and so pretty sounding. All right. This Week in Radio Tech, episode 169, with Tom Ray and also Chris Tobin. And our guest is the Senior Vice President for Engineering for CBS Radio. It's Glynn Walden. Glynn has got some ideas about the AM radio band. He says, essentially, blow it up and turn it to digital. And I wonder what that will actually sound like when I'm traveling and driving around and going through a tunnel and under a bridge. And will the disc jockey disappear like comedians have joked about for years? Glenn, tell me what the future could be like.
Well, first of all, I think that someone asked me what the experience is of driving around listening to all digital. And we did some tests, as everybody knows, in Charlotte on WBCN. And let's just say that WBCN was essentially turned into a Class A FM station. It's exactly how it behaved. You drive down the road, you drive for miles and miles and miles, and you listen to absolutely unimpaired audio. No interruptions, no noise, no clicks, no pops. It's just like listening to an FM station without multipath. And as you start to get out around the 0.5 millivolt or 0.1 millivolt per meter contour, somewhere in that range there, the radio starts to drop out. You start to lose the signal. Within 0.2 of a mile, it's gone. That's it. But up to that particular point, you drove for an hour and you had 8 seconds of interruptions and it was gone. That was it. So in an hour, that's what you had. That's what your statistics are. And that's how I describe it. It's like listening. It was like listening to a little Class A. It's up on 1660. It's 10 kilowatts. It's in an area where the soil conductivity is not real high, but not terrible. Certainly not as bad as in the Philadelphia area where I live. And that's the experience. And what happens when you go under a tunnel, if you go through a real tunnel, you lose it. If you go under a bridge, nothing happens. It just keeps on playing.
Yeah.
Like underpasses. A tunnel is an altogether different situation. You go under an underpass, nothing happens. By the way, Ubiquity spent so much time on developing that system so that it would survive under these conditions of grounded conductive structures. the research that we did, the money we spent to find out what caused all those interruptions, and then to compensate for them, was not just a matter of somebody pulling a textbook digital system out of a cookbook and cobbling together a bunch of carriers to create a system. It was a lot of research and engineering went into this. A lot of money was spent. It was not done cheaply, and it works good. Is it perfect? Absolutely not. Nothing's ever going to be perfect in the AM band. If you get enough noise, and I will tell you, in one radio we drove and we were near the half millivolt per meter contour, and it died at the half. And you turn on an AM radio in that same point, and all you heard was.
Oh, well, that's a good comparison there, and I've heard that can be true with FM HD as well. But now, so you're saying that if with this test you were doing, would you spend a bit more time describing the modulation and this test? Was the whole AM mask area used for transmitting the digital information in this test?
Yes, it was. Plus and minus 5 kilohertz.
Okay.
Total bandwidth 10 kilohertz. The total power of the digital carriers was 33 kilowatts. The total power of the pilot carrier, which is the reference carrier, and the digital carriers combined was 10 kilowatts. 10 kilowatts.
10 kilowatts.
10 kilowatt station. And so we'd have to divide that by 5. It's around 6,000.
And what
watts.
kind of bit rate did the audio compression get to use through that system?
Well, there's two versions of it. One is 20 and one is 32.
Okay.
36, excuse me.
36,
and,
okay.
And a lot of the AM stations have converted to the 20 kilobit version of the codec because there's been sufficient coding improvements that could be put into the system without changing the receiver out. One of these things about these codecs that are used in these types of systems like AAC and similar types of codecs is a lot of the information about how to decode the signal is sent in a header that goes with each packet. And so you can make a lot of changes in the encoding end and still be able to send instructions to the receiver to improve reception. So if you've watched over the years, you've probably seen improvements on XM as they've had to narrow the bandwidth more and more to fit the number of channels they had in. And Ubiquiti did a major change about 2 years ago. They claim the codec is as good at 20 kilobits as it was at 36 kilobits. I don't know if I totally agree with that, but it's not bad. Certainly not bad in comparison to listening to analog with S. Can you do that imitation again, Tom? There,
Tom Ray, what does analog sound like now with 2.2 kilohertz of audio response?
Oh, if you put your fingers up your nose, that's exactly what it sounds like.
I got to tell you, Glynn, I want to tell you about an experience I had in St. Louis years ago. I had just gotten an HD radio installed in my car. I think I did it myself. And I'm in St. Louis, and I'm going to go visit the station that the Lutheran Seminary owns, KFUO, and they have an AM. And as I recall, their FM, they have an FM, and it had an HD, and their AM was also operating with HD. And I'm driving around, and my car phone rings, and I'm yapping on the car phone, driving around, trying to multitask, and not doing such a good job. I pull up to the radio station, put the phone down, look at my radio, and I honestly think to myself, I don't recall leaving my radio on an FM station. And then I looked at the radio, and it was on KFUO AM, and it was on their HD. And my point there, and I talk about this in relation to audio processing, is that they were processing their audio, and I have no idea what brand of processor they were using. Doesn't really matter so much, but they had it adjusted in such a way that it sounded very nice. It was not all packed up and dense on the HD. It was really sweet. It was there. It was processing. But my point was my brain thought I was listening to FM on their probably 20 kilobits or just above that on their AM HD. So personally, I'm excited. I can see a day when we would go all AM HD, and I would be excited about the quality that I would hear from that. I understand about the digital cliff when you get out to a certain, but if you could switch back to an analog signal, it's not listenable at that point anyway. You wouldn't be listening to it.
That's probably the point. That at the point one the 0.5. When we do our evaluations of AM, we generally look at, say, 5 for indoor, 1 for outdoor reception. And that when we look at where we think we can create an audience from, that's going to be about it. And that means an audience means somebody who will be listening to the radio station and actually showing up in a diode or showing up on a PPM. Beyond that, it gets to be pretty iffy. I remember once I did a lot of codec evaluation when I worked at Ubiquity, and I have to say I was absolutely the wrong guy to be doing that kind of stuff, because when we first started this USA Digital Radio project, the other guys on the project used to laugh at me because I couldn't hear the artifacts. And they would say, "Glynn, you must be deaf. You can't hear the swishiness in that violin." I said, "I don't hear nothing. Sounds fine to me." And then one day, unfortunately, I learned to hear artifacts. I used to go up to the music with the Musicam people, Chris, when they were developing the Musicam, the US version of MPEG coding, which is Musicam.
Oh yeah.
And we would take engineers up there, and they'd be people saying, right there, it's right there. That's or nothing. I really wasn't good enough. But then I did learn to hear artifacts, and unfortunately, I'm never going to be satisfied.
Well, that's true. Once you learn to hear that, it's stuck in your head. So when you do hear it, it's obvious. The first time I ever heard MP3 was at a Mosley booth demonstrating putting maybe it was MP2, but I thought it was MP3 coded audio through a digital Mosley, and I thought, wow, I really can't hear the difference. And nowadays, you go listen to 128 kilobit MP3, and we know what to listen. Our brains know what to listen for now. It's different than crossover or clipping distortion that we used to listen for.
By the way, you had to learn a whole new, if you'd have been living in the 1900s, the concept of THD would have never happened in anything you do, because that's not a natural phenomena. It doesn't happen in nature, and we learn to hear that, and then we learn to recognize it, and we learn to deal with it. And these artifacts, before people heard them, they didn't know what they were, and so they couldn't have been quantified in any particular way before. I think the AM system sounds really very good. I think if you think about it in terms of 20 kilobits per second, we're taking a signal and we're reducing it from 1.5 megabits per second down to 20 kilobits per second. It really sounds real good, but I still hear the artifacts. I'll never be happy. Okay, and that's because I spent so much of my life evaluating codecs after I learned to hear these artifacts. But I'm going to give you an example, just exactly what you were talking about. One day, Ubiquity gave me this CD to listen to, put it in your car, and it was made from an AM radio station. And I'm driving down the road, and your mind drifts off. You're not paying attention. All of a sudden, I said, "You know what? You're forgetting something really important. This is coming through an AM radio station." That was a real eye opener to me. But like I said, I'm never going to be satisfied. It has a little bit of raspiness to it, and that I don't really like. One of the things I do is I try to process that out a lot. I don't really try to push the highs all the way up to 15 on AM. I put them back 9 or 10 because that's about where and that keeps some of the artifacts out, and also. Especially as long as you're running in the hybrid mode, it cuts down on the differential when you blend back to analog, so it's not quite as noticeable, because that is it's a sharp cliff to go from 15 kilohertz of stereo audio down to Tom Ray's example here.
So here's a question that's still bothering me.
I don't do it as good as he did.
Actually, I'd like to piggyback on what Glynn was saying, that, having been one of the original high power, or actually probably the original full-time high power HD radio station in the United States, you know what? I can hear the artifacts. If I listen to it, I can hear the artifacts. But then I take people like, I took people like neighbors. I took some people like my wife, and I said, "Listen to this. What do you think?" And they said, "Wow, FM." They didn't hear the artifacts because A, they don't know what to listen for, and B, they weren't listening to it critically like I was. So at some point, I think you have to kind of take a step back for a minute and say, we're doing the best we can, and how is the audience going to use this product?
Yeah, that's a great. How's the audience going to use it? Because I don't agree with you going down a slippery slope of quality. I don't agree with you there, and I don't. Maybe you're not saying that, but how's the audience going to use this product? That's a question worth asking and answering.
They're going to listen to the radio.
Yeah.
They're going to listen to the radio. They're going to listen for content. And they're not like me. And I remember when we were in Charlotte doing the testing, and I said to Russ Munchank from Ubiquity, because we were driving a Ford, I said, so I see this car has Sirius in it, not XM. He says, yeah, it's a Ford. I said, did they clean up the audio quality? Because it really used to be awful. And he said, tune it in for yourself. I tuned it. I says, oh my God, how can anybody listen to this? It's so awful. But does anybody complain? They don't get any complaints. Their audio quality is worse than the AM signal is in many cases on their channel, because they have this really terrible codec. But nobody complains. You ever see in the press line, I can't listen to XM radio, Sirius radio, because it's so distorted? No, the audience accepts it. So
no, you're right.
We're the most critical people in the whole world, us broadcast engineers.
I think for satellite radio listeners, the question isn't what's the quality. The question is what's the cost. And does my favorite channel play what I want? And I was going to ask the question: how does AM HD, either at 20 or at 30 whatever kilobits per second, compare with XM or Sirius satellite radio? Because that's where comparisons are going to happen.
I think it's probably not as good as the best XM channels.
Mm-hmm.
Better than the worst XM channels. They don't allocate their bandwidth evenly. They allocate it by whatever programming they have on there. I'll tell you what, it sounds better than any Sirius channel I've ever heard. And that's not saying much.
No, and I agree, Glenn. I've got an XM set up in my car. My wife has Sirius in hers, and we pretty much listen to the same stations. And boy, let me tell you, I much prefer listening to XM in my car. If I have to listen to it, it's like, oof. But you're right. I mean, and if you have to do a direct comparison, the mid to better quality XM channels are what the AM sounds like on HD.
Yeah.
So okay, here's the question I've been wanting to get to.
It's probably favorable, I'd say, Tom, wouldn't you? To the XM experience.
Oh, definitely. It compares very favorably. They're very, very close.
All right. Long distance travel. If I'm listening to 50 kilowatt WLW out of Cincinnati and they're all digital, there's no analog mode, what could I expect to hear daytime? Or what could I expect to hear nighttime listening digitally?
Well, of course, I really don't know. But if you think about those stations, the half millivolt contour is hundreds of miles away. So that pretty much consistently in all the tests we've done on any station, whether it was WTOP where we tested all digital, whether we tested on expanded band in Cincinnati, or we tested on expanded band in Charlotte, pretty much it's consistent. Somewhere around between the half and the 0.1 is where it fails, typically about 0.2. So the 0.2 for WLW in Chicago probably goes out 300 miles. I don't really, I didn't pull a map. I didn't draw a map on it and see. Yeah. But here's how I look at it. I told Dan Mason, I said, WFAN in New York, if it was transmitting on all digital, would be perfectly receivable driving around Philadelphia, but you will not get it indoors. But you will be able to get WFAN anywhere you go in New York City, including indoors, except in real high-rise buildings. Obviously, there's limitations. Yeah. It's complete signal blockage. So, so what does that do? That means that some of these stations, like WLWs, they become monsters. I mean, nobody wants to listen to a 0.2 on WLW unless they're playing a baseball game and a guy just hit the bat.
Right.
As I always say, when they crack the bat, nobody's changing the channel, no matter how bad it gets.
You're right. That's a great way to put it. So what about nighttime coverage? What about Skywave? How does digital work with that?
Well, it doesn't work on Skywave. It intermittently works. Now, if you want Skywave, you can adopt the DRM system. It's designed to work on Skywave, although they don't have a clue about how to make it work on a moving car. But so this system was designed for U.S. broadcasters to deliver to the ground wave service area the highest quality signal possible in stereo, because that's what every broadcaster wanted. They wanted stereo. They wanted to have FM equivalency.
And DRM doesn't have the kind of time diversity that HD has, right? With HD, you've got time diversity. That's why you can go through under a. Okay.
That's part of it. Remember, one of the things about digital channels is they normally take about a minute, a second and a half or so to lock up, maybe 2 seconds. Ibiquity designed this all digital system so that it locks up instantly. And then that's one of the channels. The other channel that's out of time with that by 4.5 seconds is the more robust signal. So you lock up first on a signal that doesn't have quite as much interleaving in it, and it locks rapidly. And then the two are added together while you're driving around to compensate, like when you go under bridges and stuff. Since there is these two signals that are out of time with each other, it compensates when you go under these overpasses. It maintains continuity as you continue driving.
Yeah. All right. If every AM station in the U.S. if they all went digital, full digital, no blended mode, full digital, would everybody just keep their same power level and the same directional patterns for directional stations? Is that what you're thinking?
That's what I would think, but I don't know what the FCC thinks. But that would be, since the whole Ibiquity system was designed to work with the existing allocations, didn't require a new set of allocations to work. There's no reason you can't maintain your existing powers, and your DX50s or your 3DX50s or your Nautel NV50s or NV10s or DX10s or all are designed to work at full carrier power, 50 kilowatts or 10 kilowatts or 25 kilowatts, as they come from the factory within the all-digital mode. No modifications are needed to be made to the transmitter to operate at that power level.
Do you think that how much attrition do you think there'd be from small stations who just say, oh, heck, I ain't going to buy all that digital stuff. We're just going to throw in the towel and concentrate on our FM. You think that would happen a lot?
Well, I think that's a problem, okay? And I think it's a problem that's going to be one of the biggest issues that comes up. There are stations that are in Texas that don't have cap compliant equipment. You know why? They can't afford it. It's $2,000, and so if they can't afford to buy cap compliance in order to be compliant with the FCC rules, this is not going to be an option for them. Now, I think that let's suppose that we decide that in the year 2022 we're going to turn off analog. I think they're going to be opportunists walking around looking to see what they can do to build up an operation for themselves, that they can take advantage of this terrific new service that opens, if anybody's still listening to radio, which would be the other problem. Okay.
Yeah.
Well, so far we've had no erosion. So but there's no guarantee that'll go on forever. I will tell you that analog is going to lead to the demise of those numbers because it does not deliver the same kind of quality, reliable service that they get with other services.
Yeah. Wow. Chris Tobin, I'm sorry, I've been talking the whole time. We brought Tom in a couple times. Chris, I'm sure you've got some comments and maybe a question or two for Glenn. You used to work with him, so probably you know everything that's going on in Glenn's mind. What would be your comments at this point, Chris?
Oh, my comments at this point, working with Glenn it was a pleasure, and I look forward to doing it again. But I would say I have to agree with Glenn on all the topics, all the talking points. I think it will be a tough way to move. I like the idea of picking a date in the future and say, okay, guys, this is the way it's going to be, and then work toward finding a technology that will make it function. Then there's the question of affordability. And Glenn's right. There are many stations. I've worked for a few, did some contract work with, that cap compliancy is a difficult thing, and so are a few other things they have to do. So it's going to be a tough run. Analog, yeah, how many years left before it starts to become a nuisance for people in the cars or at home? You know, it's going to be a tough one. But I still think AM stations that have the currently have their signal that people recognize, they use it, they can hear it, they should be now looking at digital solutions and start leveraging those solutions and say, hey, you listen to us here, but by the way, here's a new place to find us. Either it's on the smartphone, new digital radio, internet radio on their kitchen table, or something in the car. And just this way, it just gives the impression that, hey, my favorite station, whether it's sports, news, talk, music, whatever it is that the AM station is doing, can now be found in their more familiar digital world that they're now growing into. And then, and then if the digital date comes along and everybody switches, maybe we'll be in lucky shape. I don't know.
Well, we've been talking about the transmitter side. Any kind of receiver mandate? If you're going to build an FM radio, you got to build an AM HD radio, which means you got to pay a fee to iBiquity. And do you mandate at this point that iBiquity can't charge radio stations, but you're forcing them to move to this tech that has fees associated with it? What do you do? I mean, my stations, none of my 8-9 radio stations have moved to HD radio because it's not in our budget. We can't do it. And I don't know if we were forced to do it. I don't know what we do.
Yeah,
Glenn, do you have any?
I
don't have answers to that, obviously, Kurt. I think it's it's a process that somebody needs to start talking about and start figuring out how you do it, because the alternative is nothing. You're riding the train to where it runs off the end of the track. Ultimately, is what's going to happen, and I don't know if it's really true, but if your radio station burned down in one of your markets, I guess you wouldn't rebuild it.
That's a good question. There's a couple that we probably wouldn't rebuild, and there's others that we would. Yeah.
I mean,
and I know there's this pushback to having to spend money that you didn't have to spend before to do this what you perceive as the same thing as you were doing before. And I, you know what, as a station owner, I guess and I'm not the guy that writes the checks. Thank goodness, I've got a partner who owns the majority. He writes the checks, but he wouldn't mind a one-time check to iBiquity and to iBiquity via Nautel or Harris. Or BE, you're buying the technology through them, but it's an annual fee. I think he's got a problem with.
Not true.
Tell me.
It's a one-time fee when you get your license.
Okay.
It's a one-time fee.
All right. I guess I was wrong about that. I thought there were an annual re-up, or your HD would go off the air.
There are fees for multicast on FM.
Okay.
They are 2% of revenue.
Yeah,
I believe. Okay, they're small. And as I put it to Joel Hollander, you don't spend the 2% and you have no income to give the 2% from anyway. Or if you get some income from the multicast, would you rather have 98% than no percent?
Yeah. Okay, good. Well, that clears that up totally. But 2% on an HD2 for us, that would be a yacht payment, and I'm not sure we want to give that up. All right. Well, Glenn, what happened?
Nashville? Wait, you have yacht?
and you'll note, Glenn, that he didn't invite us on the yacht.
Oh, this is our stations in Pongo Pongo.
I gotta open up Google over here and take a look at Nashville.
No, this is in Pongo Pongo. So, Tom and Chris, I'm sorry, I've been yapping the whole time. Anything else you got to ask Glenn right now before we have to go?
No, and I agree with Glenn. A date does have to be picked, and hopefully not too soon. I went out and worked on a 32-year-old transmitter the other day for a radio station that has one employee. I mean, they had one guy. That's it.
I didn't see you at our stations, Tom.
Well, you blinked. You missed me. Yeah. And very bluntly, they were wringing their hands over the fact that they might have had to change the transmitter AB switch contactor for I think it was $1,100. that was a lot of money for them. And if they had to replace that transmitter right now, they'd probably sign it off and throw in the towel. Maybe not, but I mean, they're in a tiny, tiny market, an unrated market. And, stations like that, there's going to have to be a time period and a way for stations like that to get out, either say, hey, okay, we're going to turn the license in, or, hey, okay, we know there's going to be 10 years, so we need to start putting money in the bank now, to make this happen.
I didn't even think about that in advance, about time. 10 years, you start putting money in the bank. Because Glenn, that's exactly what I would do.
Oh, Glenn, you alluded to something, though. You said business opportunities. I can see people with venture capital money, going to these small operators and saying, hey, we'll buy your station, we'll buy your station, we'll buy your station. We'll buy your, we'll take it over. And they go in and spend the minimum they have to get on the air with HD only, turn the switch on, and they may not have any income for several years, but they may know that going in. I don't know if people would see that. Yeah, it seems like, wasn't there a time, 15 years ago, when it seemed like Clear Channel was buying up a lot of 50 kilowatt stations, and people were scratching their heads wondering, why is Clear Channel buying all these 50 kilowatt stations? In Laramie, not Laramie, but in oddball places, we saw them buying stations, and it was just about the time that HD was coming out. And we thought, well, maybe they're going to take them all digital. Maybe they got a plan to do that and make a lot of money doing that, or flipping the stations once they're digital. I'm not sure that ever panned out, but
I certainly don't think so.
Some people will see an opportunity.
Let's look what's happening right now on TV. Michael Dell's buying up TV stations, useless TV stations, so he can turn them off. And he's going to turn the license in, and he's going to he'll then participate in the auction, and he'll get his money, more money than he paid for them. And that's his goal. So those stations he's going to turn the license in and not take a new channel, and just take the money.
So he's in the real estate business, speculating.
He's in the RF real estate business, I guess you'd call it.
Yeah.
And his name prominently comes up as buying TV, upper band TV stations, low power ones and stuff. And he's waiting for the auction.
There's another question I meant to ask, and so I'll ask it now and see if there's any kind of a short answer. Where the AM band sits and the behavior of radio waves from 500 kilohertz to 15, 16, 1700 kilohertz, the way that stuff operates in our modern world, is there a better use for that spectrum than entertaining people with analog or digital signals? Is there a better utilitarian use for that spectrum, Glenn?
Well, I could obviously be wrong, but when I was on the panel, I said that that in the case of television, when they did their digital transition, the FCC loaned them a channel to move to because the recovered channel was worth something. To my knowledge, there's no more useful function for the AM band than for broadcasting. And the spectrum is useless. So if the FCC is not going to swap these AM stations, a channel in the AM band for a channel in the FM band, and they're going to auction it, and people are going to pay.
Okay.
To get it.
All right. So there's not some wireless technology. There's not some utility control technology. There's not something else that has a better claim to the band because of its efficacy in our society and usefulness than broadcasters broadcasting content in that area.
I have never been able to think of another cause. Someone said, well, it's treat it like a railroad track, and you're going to change the cars that run down the railroad track. So what would those cars do? And that's how people have kind of conferred on me a way to analyze that. The tracks are just too narrow, and it's a very hostile environment. By the way, operations in the AM band are expensive by comparison. You have land, you have real estate, you have towers, not a tower, you have towers.
Yeah.
Ground systems, and all this balky stuff that goes bad all the time. It's not a sealed. If you take a look at an FM system, it's a sealed system. There's no it doesn't get rained into. It has pressurized lines. So it's a lot more. It should be a lot more stable. Also, every one of those towers are lightning rods, and so they attract lightning, and
sure do.
And the quality and the quality of a lot of the AM stations is such that they suffer severe damage from lightning because they weren't very well built to begin with. They're not well grounded. They weren't well engineered, and they're still not well engineered, and so they suffer damage. It's not a real good place to do business. Wireless. One of the problems that you face with wireless is antenna size. I don't think the wireless guys are going to be looking for our FM spectrum because the antenna needs to be too big.
Yeah.
Likewise, it's not real likely that you're going to see too many people looking for AM for wireless spectrum because the antenna size is a problem. The other problem is that anything that's going to offer any type of coverage, digital devices such as digital receivers, pagers, and stuff, or smartphones, all generate a lot of noise. So the antenna has to be located at a point distant to the device that's being used. And so you can't have, it's really hard to put an AM antenna and a digital receiver or any kind of digital device in the same box. That's how come you don't see any smartphones with AM receivers. They only have FM receivers in them.
Yeah. Wow. Hey, Chris Tobin, any parting thoughts?
No. I think we've covered everything. I wish I could find a silver bullet, but I don't think there are any.
Well, I think whatever we do, it's going to be painful. It's going to be painful to die a slow death. It's going to be painful to switch to a different system and blow up, the millions of receivers we have now. And I think what a lot of engineers and people in radio have is an incredible emotional attachment to what we do now. I have some emotional attachment to that. There isn't a radio in my, you know what? I do have one HD radio in the other room, but there isn't a radio in my house that will work after we do something like this. And people in the chat room have said, well, what about, community service? What about, serving the public? Well, you can't serve the public if you don't make money. And yeah, I know there was a time you work hard, you make money, but I don't know for an AM only broadcaster how that time is going to continue with all the continued encroachment that we have from so many things. And Glenn, you said we haven't seen much erosion or any erosion of radio listening, but as of right now, we still don't have LTE in the dashboard as a standard thing, at least maybe a little here and there. But I mean, in a few years, when every car just comes with LTE with a free year, and it's not just XM or Sirius, of course, it's anything out there on the planet, including Pandora. What's that going to do to erode AM and FM listening? I got to believe it's going to erode a lot.
Well, good luck. LTE system, when fully built out in the year 2020, will be able to serve, in New York City, will be able to serve around 300 to 400,000 simultaneous users.
Yeah.
Because streaming eats up all the bandwidth. And let's see, WINS, how many listeners do they have, Chris, in any given time?
We're talking 2 million. To go by
well, so if everybody turned on their streaming radio and tried to tune in their favorite radio station tomorrow, it would shut down the entire cellular system. There's not enough capacity.
I've heard that, but you're the first person to tell me some numbers associated with that. I would like to do
a white paper I read, and I'm sorry I don't have it in front of me, but it was a white paper written.
Oh, and I'll just believe you. I'd like to have a show, get somebody on the show who can tell us about those numbers and what these systems can actually handle. Because, broadcasting, obviously, more listeners does not decrease. I mean, doesn't use up any more resources. It's the same resource if there's one or a million.
Well, remember, you can increase the number of listeners on that and number of users on that by decreasing the cell size.
Yeah.
But at some point, you're getting down to where there's a cell every block. And the cost now goes astronomical. It's like when we originally looked at the Eureka system. To put FM in New York and replace it with the Eureka system would have taken 80 transmitter sites. How many? Do you really think even with the kind of revenue the radio stations were generating in 2001, 2002, that they could have supported 80 locations with rents and everything to go with them?
Yeah, that's a bunch. And I think they're finding that to be somewhat difficult in Australia, where they are doing that with a much smaller population, of course, and not as many sites. Hey, guys, we got to go. We're past our time by a lot. Glenn, this has been fabulously interesting. I'm so glad you came on and talked about your vision for the future of the AM band. And although it looks painful, I don't see a way to continue the way that we are, and so I must admit that I agree with your premises and perhaps your conclusions too.
Have a good day.
Thanks for being here.
Guys.
All right, guys. Hey, you've been
Thanks,
watching
man.
and listening to This Week in Radio Tech, and Tom Ray from the Hudson Valley of New York, thank you for being with us. I appreciate you very much.
Well, it's always good to be here, Kirk. Always good to be with you and Chris, and it was great having Glenn on tonight. Nice to see him come on the show. He's a great guy, and very bluntly, one of the smartest guys I know. So.
Oh, he is. I always feel dumber when Glenn walks in the room. And Tom, people can find you on the web at
TomRayConsulting.com.
That's right. And Chris Tobin. Oh, I'm sorry. What, Tom?
Oh, yeah, no. I was just going to say there was one thing we were going to mention tonight and haven't.
Oh, that's right. We got
Yes.
hit it fast. Tell us.
Yeah. Well, there's for the broadcasters out there, there is a PSA that was released today about the emergency alerts you can receive on your smartphone. The problem is, it uses the EAS two-tone attention signal, which is blatantly illegal under Rule 11.45 of the FCC regulations. If that happens to show up at your station, you might want to go tell the PD. You might want to go tell the general manager. You can't air it.
Now, just to be clear, it's not illegal to run these tones through your cell phone. It's the PSA about the tones that runs the tones that's illegal.
Right, because the rule states that on a broadcast station, you cannot use either the EAS codes or the attention signal with anything but an actual EAS alert or an EAS test.
Now, I got to say that if the people at the ad council or whoever made these PSAs were smart and they get some feedback and advice about this, how about if it's the old EAS two-tone, just move the frequencies a bit, and it won't be the EAS tone, and you can simulate what people will hear, even if the frequency is slightly wrong?
No, you can't.
Why not?
Because the regulation goes on to state you cannot even simulate.
Not even with the wrong tones.
The tones infer something. They're inference.
Right, so you can't even simulate. And the scary thing is, the Ad Council webpage said that this was sponsored by FEMA.
Oh,
they should know better.
You would think. Then again, Tom and I have been to some FEMA meetings. That's all I'm going to say.
Yeah. And there was not a keg involved or a goat.
Okay. Chris Tobin, you've been with us from the folks at Musicam USA. Thanks for being with us. And people can see you at musicamusa.com, right?
Yes, absolutely. It's been a pleasure. Glenn, it's good to see and hear you again. And Tom, as always, and Kirk.
All right. And our show's been brought to you by Omnia Audio and the Omni 11 audio processor. Thanks to the GFQ network in Queens, New York. And thanks to Andrew Zarian, the next media mogul, taking over the world, starting at the East Coast and moving west. Thanks for you being here. We'll see you next week on This Week in Radio Tech for a War Stories edition. See you then. Bye, everybody.
That's all the bandwidth we can pill for this week. Another twort has propagated, and all the transmitters and audio equipment live happily ever after, thanks to the handsome engineer and his kind, benevolent care. We'll be back next week.
Lord willing and the creek don't rise.
This Week in Radio Tech. Subscribe to iTunes and you'll never miss a show. Search for This Week in Radio Tech in the iTunes Store. Soliciting is strictly encouraged. If you like today's show, tell a friend. If you didn't like it, we were never here. Kirk Harnack's wardrobe provided by the Salvation Army and the Red Cross Disaster Relief Services. Hair and makeup provided by Penny Lope Garcia Hernandez Weinberg.
He's unique, wouldn't you say?
I just want to get it over with.
This ends this transmission. Tango, Whiskey, India, Romeo, Tango. Signing off. Okay.